Okay, welcome to JC Connect. In the previous class, we were discussing about the iron. There we have covered the importance as well as the significance of that iron. Today we'll start with the available chlorine in bleaching powder. The way this available chlorine in bleaching powder is important. Okay, and why the chlorine is used? The chlorine we already know and you already studied in water supply engineering that the chlorine acts as a disinfectant. Chlorine acts as a disinfectant and it is in the form of CaOCl2. The formula of bleaching powder is CaOCl2. Then how this bleaching powder is prepared first? Okay, always the chlorine, it is a halogen compound. Okay, and it is unstable in nature. The unstable means okay, when you open this, always the tendency is to escape. Tendency is to escape. Okay. Even this the whatever the CaOCl2, it is a combination of Cl2 and CaO. CaO is lime. CaO is the lime, which is unhydrated. Unhydrated lime. Then CaOH twice, which is hydrated lime. Hydrated lime. Then how this will be prepared? See, they will take the lime plus this Cl2. They are going to introduce the chlorine gas into lime under pressure. Okay, and the percentage available or percentage dissolution will be roughly, it will be around 40%. It won't more than the chlorine percentage in bleaching powder will not be more than 40%. So that is a maximum dissolution that you are going to expect in bleaching powder. You cannot get 80% of chlorine in bleaching powder. The percentage available in um, chlorine in bleaching powder is less than 40%, not more than 40%. And one more thing, when you introduce into this bleaching powder, you have to pack it immediately. Once you immediately open the bleaching powder pack, normally you will get pungent smell. That's nothing but the escaping of chlorine gas. Immediately it will escape. If you open the bleaching powder packet, what will happen is that whatever the 40% or 20% you leave, within half an hour, okay, within 30 minutes, all the chlorine gas is going to escape. Okay, that much it is unstable in nature. Okay, that is why, and it is very dangerous also for if you expose to the chlorine gas, suddenly you'll become unconscious. Okay, that's the main important health significance. So that is why always it has been stored in this lime. Okay, and especially chlorine gas should be very careful. Of course, it is purest form of chlorine. Okay, pure form of chlorine, pure form of chlorine. Okay. But still it is dangerous, but it can be used with the in treatment plants it is recommended, but with precautions. Okay, it requires a skilled person to operate. Then chlorine and its derivative inactivate. Why this chlorine is used? It is used to disinfect the pathogens which are present in the water. Then how exactly it is going to disinfect? First, what it will do is that it is going to inactivate the enzymatic system of pathogenic bacteria. Once, if the pathogens are there, if you add the chlorine, first it will attack the enzymatic activity or enzymatic system of the pathogens which are present in water. It also oxidizes the organic substances and soluble iron and manganese at higher dosage. Okay, we already studied the um, breakpoint chlorination. Okay, the breakpoint chlorination is, it will be like this, go like this. The breakpoint chlorination, here the many stages will be there, A, and here it will be B. Okay, at this point it is C, and this will be D. So this is the graph is versus the dosage in milligram per liter versus the residual chlorine. This you already know. Okay, so this here you can is this point, if you add the chlorine here, the oxidation of iron, Mn, etc. From here to here we can say um, formation of chloramines. Formation of chlorine. From here to here again, okay, the destruction, you can call it as destruction of pathogens. And from this point we can call it the breakpoint chlorination. From here to here, C to D, this point is a, whatever you will get it, is a free chlorine or residual chlorine in terms of milligram per liter. Okay, if you see overall the process of disinfection process, this curve has to follow. If any activity or if any disinfection process is going to happen, okay, it has to follow this curve. It has to follow this curve. If it is not following the curve, means some problem is associated with the organic matter. If any imbalance is going to happen with the organic matter content in water, so this slowly this curve is going to change. Okay, that you have to check it out. So then why, we have to find out the available chlorine in bleaching powder. That is very important. Okay. See, the main reason behind to find out the available chlorine is that we should know how much we have to add bleaching powder. Okay, based on the content of chlorine, based on the content of chlorine in bleaching powder is much more essential. Sometimes what will happen is that I already said that the available chlorine in bleaching powder is varying from 0 to 40%. Some of the bleaching powders it will be there 20%. Some of the bleaching powders it will be there 5%. If it is 5%, you can add extra. If it is 40%, you have to add very less. Okay, that is the thing you have to understand. So, but what will happen is that most of the time the manufacturers, they say that in the packet they will mention it that it is 20%. But if you store for longer time, what will happen is that it may come down, but we don't know how much it has come down. Okay, with that reference to, or that is one thing. This is one thing we have to find out. With this reason, we have to find out the available chlorine. And second thing is that some pathogens may require more chlorine, or some pathogens may require less chlorine to deactivate the enzymatic activity of their metabolism. Okay. So that reason we have to find out, or we have to do this experiment. Okay. And in water treatment process, this play a very important role. So it also oxidizes, that I already explained. Oxide organic substances, soluble iron and manganese at higher doses. For efficient chlorination, water should be intermixed thoroughly with the chlorine added. Okay. Let to stay in contact with reagent for 30 minutes. Okay, 16 when chlorination is combined with ammonization. Uh, this I'll explain it why it is required before it will be delivered to the consumers. Chlorine may be applied in a gaseous form or in the bleaching powder, but here in our laboratory experiment, we are following the bleaching powder. Okay. Then what is the significance? Chlorine is available in different stages. I already explained. The gaseous, liquid, also in solid. The bleaching powder is a stack lime. I already explained that is CaOCl2. It is a stack lime through which the chlorine is introduced into water. So this test is useful to assess the quality of bleaching powder also. Very important. Okay. Quality of the bleaching powder. So also it is useful to estimate the amount of bleaching powder required to disinfect the disinfection of water. Means, for example, you have assume that you have 100 pathogens are there. 100 pathogens are there. For to kill the 100 pathogens, how much bleaching powder? How much bleaching powder I should add? Okay, that is we should know. This is a significance. Then what is the principle behind this experiment? So the principle behind the reagents, whatever we are using in this, is that first one, that is bleaching powder. Then we are using potassium iodide. Then we are using starch. It is similar to the DY experiment. The sum of the reagents K is similar, and starch also we are adding in the DY experiment. It is similar to that. Okay. Then what is the principle? So the chlorine, which is a strong oxidizing and liberates iodine from the iodide ion. Okay, once you add the potassium iodide to an reacting reagents, if we are determining it, okay, it is going to release iodine from iodide ion. So then the starch also we have to add, which acts as an indicator. The starch gives a blue color with iodine. The liberates iodine in titration with sodium thiosulfate. Also, we are using in DO. Also, we are using Na2S2O3. Na2S2O3 is nothing but sodium thiosulfate. So, which is a titrant? Okay, which is titrant. So, the disappearance of when you titrate against this. Okay, the disappearance of the blue color indicates the completion of the reaction with a free iodine, which is converted to back to iodide. Okay, so the principle is that if you are saying with the principle, always see what color it is changing, and when you add any chemicals or any indicators, what color to what color it is changing, that you have to note down. Okay, here one thing is that when you add the potassium iodide, so what color it is changing, when you add starch color, what it is changing, so finally what it will remains. So then this is what the reaction is going to happen. To remember three reactions. When the chlorine gas, which is combining with Ki, it will form KCl and the release of iodine. Okay, the iodine is going to release. Then this iodine, which is going to combine with starch, it will give the blue color. When iodine, which is going to mix with sodium thiosulfate, which is a titrant, it will give Na2SO4 and O6, and again sodium iodide. Okay, this is the principle behind the experiment. Then how to prepare this bleaching powder solution in the laboratory? So what you have to do is that, so it is the concentration is 2.5 gram per liter. Then mix 2.5 gram of fresh bleaching powder. Very important this. Okay, in about 150 to 200 ml of distilled water thoroughly. Allow to settle. Okay, transfer the supernatant solution to volumetric flask. Add again distilled water to a remaining and continue the above procedure till volume reaches to 1 liter. And very important, care should be taken while mixing. As far as possible, when you add bleaching powder, 2.5 gram per liter, okay, always when you are mixing, try to close it, okay, and don't allow, for example, if you're mixing in beakers, you mix it and close cover with the top portion so that the chlorine should not escape. Suppose if you are keeping, if you are repeating this procedure, what they have recommended, if you are opening or if you don't cover it, chlorine will escape. Then you won't get any chlorine in bleaching powder itself. Okay, always I said that it is the tendency is to escape. It is unstable in nature. Okay, so whatever the 2.5 grams you have to wait and mix it to 1 to 50 ml of distilled water thoroughly. Then only the supernatant. What will happen is that it is a lime. You know the property of lime. Lime always has a tendency to settle. Then 1 to 200 if you are using 200 ml sample every time, then you have to make it for 5 times, okay, so that it will become 1 liter, 1000 ml or 1 liter, okay. Once it is prepared, okay, once it is prepared, then the procedure called standardization you have to do, standardization procedure, okay. This standardization procedure and this, of course, we will finish it. This standardization, however, why you have to do the standardization? To check that whether the prepared normality or the prepared concentration of sodium thiosulfate is correct or not. For example, you will prepare 0.025 normal of Na2S2O3. Check that whether it is same or not, the prepared is correct or not. Then how to do it? So take 10 ml of potassium dichromate. Okay, K2Cr2O7 is potassium dichromate solution in a conical flask. Then add 2 ml of 2 normal of hydrochloric acid and a spatula of or potassium iodide powder. Small amount of potassium iodide powder you have to add it. Then solution turns to brown color. It will turns to brown color. Titrate again a sodium thiosulfate solution till color turns to pale yellow. Add 0.5 to 1 ml of starch solution. The color turns to blue. So continue the titration till the blue color becomes colorless. So calculate the normality of sodium thiosulfate solution using N1V1 is equal to into V2. Okay, this is how we have to do it. Then how will find out the available chlorine? So what you prepared now 1000 ml, okay, of bleaching powder solution. Bleaching powder solution you prepared it. From that you take 10 ml of bleaching powder solution in a conical flask and 5 ml of 2 normal sulfuric acid or HCl, both are fine. 5 ml of 2 normal sulfuric acid solution and 1 spatula of potassium iodide. The solution turns to brown. Titrate it against sodium thiosulfate till color turns to blue. So add 0.2 0.5 ml only when you have to add that when it turns to pale yellow. You have to add 0.5 to 1 ml of starch solution. The color turns to blue. Continue the titration till the blue color colorless. Same how you did the standardization procedure. The same method you have to follow, but we are not adding the potassium dichromate reagent there. Then find out the available chlorine by weight. Okay, using normality of the sodium thiosulfate solution, then volume of sodium thiosulfate, then 35.46 multiplied by 100 divided by volume of sample taken. For example, if you have taken 10 ml, you write it. Then weight of bleaching powder, it is 2.5 gram. Okay, we have taken 2.5 gram. Okay, this is overall about the experiment about available chlorine in bleaching powder. And one more thing, even the available chlorine in with milligram per liter also you can do it, but here it will be normality of sodium thiosulfate solution Na2 S2O3 multiply by V Na2 S2O3, then 35.46. Here in place of 100 you have to replace with 1000. Then here only volume, that is 10 mm. If you are find outing in available chlorine in bleaching powder, you have to follow this. This is V and this is N. This is your explanation of the available chlorine in bleaching powder experiment.